Hey there, my geometry peoples. Today we're talking about surface area and volume of prisms and cylinders. Now, one of the greatest mysteries of the world is what is the difference between surface area and volume? Every year you hear that question. Alright, well, I'm about to drop the knowledge on you. Now, surface area versus volume. Surface area, think of if we had a box. Alright, think of if we had a box. Now, if I were to wrap that box, surface area references to the outside, so think outside the box. So if I were to wrap these 1, 2, 3, 4, 5, 6 sides, how much paper would it take? So it's the amount of space on the outside of a figure. Alright, then volume, think inside the box. Alright, let's say this was all measured in inches. How many pieces of paper or cardboard an inch thick could you stack inside of there to cover the entire space inside of the box? And that's what we're measuring with volume. So surface area is the space outside that you can actually touch and feel, and volume is the space inside. Alright, so those are the two things. Now, if we're talking about a prism, alright, first we'll start with prisms. Now, to find the area of a prism, you could find the area of this box, and this box, and this box, all 6 of them, and add them up. Alright, but that's a little tedious and takes some time. So back in the day, they came up with some formulas. Now, these formulas are as follows. The lateral area is P times H. P being the perimeter of the base. So perimeter of base, and H being the height. Alright, the height of a base like you normally. So perimeter of the base would be adding up these 4 sides here. Alright, and then multiplying by how tall it is, instead of trying to find the rest of them. Now, lateral area references 1, 2, the back side, and the bottom side. So those 4 sides. The lateral area is just the space around. It does not include, alright, the 2 sides, which are our bases. Now, with a rectangular prism, it can get a little tricky. Alright, we could call our base the top and the bottom. Typically with rectangular prisms, we talk about the base being the side it's sitting on. However, the base could be 2 parallel sides, so of the same shape. So we actually could call our bases this way. No matter which way we called our bases, we would get the same answer. But for the sake of consistency in our answers, we're going to say the base is what it's sitting on. So the lateral area could also be this direction around as well too. Alright, so B stands for the area of the base. So if the base was a rectangle, it would be the area of a rectangle. We could have triangular prisms, in which case the base would be a triangle, and you'll see in the next one. Or we could have a hexagonal prism, in which case the base is a hexagon. Alright, so these are the formulas we're going to use. So for surface area, this is the big one, and volume, this is the big one. But you really, if you notice, the lateral area is part of that. So it's 2 pieces. First you find all 4 around, and then the 2 bases. Or all 4 around, and then the 2 bases. Alright, we combine it all into one formula. So let's see how this works here. Alright, so we're finding the surface area and the volume of each figure here. Alright, let's zoom out a little so we can see the whole picture. Alright, so in this case, we're going to use this 7 by 9 piece at the bottom here as my base. Alright, so that's going to be my base. So let's just find each piece of the formula. We had the perimeter of the base. Well, it's a rectangle, so 7 plus 9 plus 7 plus 9, because the opposite sides are congruent, gives me 32. So I know the perimeter of my base is 32. The area of the base is just a rectangle, so base times height is 63. And then the height of my figure, well, how tall is my figure? In that case, it's 14. So to find the total surface area, it's perimeter times height, so 32 times 14, plus twice the base, so 2 times 63. Again, what the lateral area found was 1, 2, 3, 4, the 4 rectangles around, and then twice the base is the top and the bottom, so that's why it's 2. So we find the area of 1 and just double it. So 32 times 14 is 448, and 2 times 63 is 126. So when you add those 2 together, we get 574 feet squared. It's still square feet. All right, just like area. Now for volume, It's simply area of the base times the height, which is nice because we have all our information already from the surface area. So the area of my base is 63, and I'm multiplying it by the height of 14. When you get that, you get 882 feet cubed. Volume is measured in cubic measures. All right. So that's a rectangular prism, surface area and volume. That's not too bad. Now, here we have a triangular prism. Now, we have to be careful. We're going to use a triangle as my base. And I know it's not sitting on the base, but there's two parallel triangles. All right, so my lateral area is actually going to be this piece here, because the perimeter I'm going to find is here, and we're going to multiply it by a span of 9. All right, so in this case, it's a triangular prism, so the two triangles are my bases. Typically, if it's not a rectangular prism, whatever, there's two of, because we have two triangles, and those are three rectangles. So the perimeter, well, 5, 12. If we do Pythagorean theorem to find the third piece, we know that's a 5, 13. That's a triple we should know by now. So the perimeter is 5 plus 12 plus 13 gives me 30. The area of my base is a triangle, so 1/2 times base times height, which is also 30. That's just a coincidence. They happen to be the same. And now the height of my figure is 9, because think about it. If I did stand the shape on my bases, it would be the height of 9 meters. So surface area, I have perimeter times height plus twice my base. So that's 270 plus 60 gives me 330 square feet. All right, now for volume, area of my base is 30. My height is 9. So 30 times 9 gives me 270 cubic feet. I'm sorry, those aren't feet, those are meters. My bad. Good thing we fixed that before moving on. All right, so that's prisms. Now let's talk about cylinders. Okay, cylinders aren't much different. If you notice, they're the exact same formulas. Prisms and cylinders have the exact same formulas. The only difference is, think about this, what's the base of my cylinder? The base of my cylinder is a circle. So now the perimeter is no longer adding the sides, but my perimeter is the circumference of a circle, which we know to be 2 pi r, or I like to use pi d. All right, so that's the one I'm going to reference in this video. Now the area of the base now is the area of a circle. So the area of the base is always going to be pi r squared, and my height is still my height. Okay? So the only difference is now it's the exact same formulas, but we're dealing with circles, so my perimeter and area have altered a bit. All right, so let's try two of these. Okay, surface area and volume. Zoom out a little more. Get a good picture here. All right, so here they're giving me the cylinders. This has a diameter of 22. So the circumference or the perimeter of my cylinder is simply diameter times pi. So that gives me 22 pi. All right, now the area of the base is pi times radius squared. If my diameter is 22, we know my radius is 11. So the area of my base is 121 pi. And my height is simply the height of the cylinder is 14. So surface area is perimeter times height plus twice my base. Now it's a little different because we're dealing with pi, and we're going to start with exact answers. Now if we were doing a word problem and we asked how much water would it take to fill this, you wouldn't say 121 pi cubic centimeter. That doesn't make sense. People don't talk like that. But for our sake, for mathematical sake, we want to be as accurate as possible. So we are going to use exact answers. So this is 308 pi plus 242 pi. Now because they both have pi, we can combine them, kind of like terms. So we get 550 pi meters squared. Now for volume, we take the area of the base, 121 pi, times my height, 14. 14 times 121 is 1694 pi meters squared. All right. We got one more here. Why don't we do this? Why don't you guys try this one on your own and come to class tomorrow and we'll start there and check our work. Alright, thanks. See ya.